everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for our subject Microcontroller and Embedded Systems Design having code KC 061, what we have covered, we have completed our 3 units, and in 4th unit we have covered our 70% portion of the unit number 4th. So, unit 4th is all about the Internet of Things. So, in the previous lectures we have covered the IoT characteristics, IoT architecture, what should be the layers of IoT, what should be the infrastructure of IoT, and in the previous lecture we have started with the hardware platform that can be used in our IoT system. So, in our hardware platform we have studied about the what should be the hardware, what should be its complexity, what type of hardware we can use in our IoT system, what is IoT wireless technology we have seen in our previous lecture. So, in this lecture we will study the hardware platform IoT, under which we will study memory, WSN in IoT and techniques used to save energy. So, under this we will study about the, so these are the table of contents that we will cover in today's lecture. First one is the differentiate between various types of memory, because we are using the processor in our IoT system. In processor we have a memory units. So, we need to study about the what type of memory that can be used in our IoT based system, that is a memory. Under this we will study the memory hierarchy, what should be the hierarchy of the memory, CPU cache memory, virtual memory, and the types of memory, main memory we will study under these topics. After that we will overview of wireless sensor network towards Internet of Things, that is under which we will study the integration of WSN with the IoT. So, WSN is one of the main technology that can be used in our IoT based system, under which we will study the architecture of WSN. We will see only the introduction part, not in detail what should be the various components of WSN that can be used in our IoT based system. After that we will, last topic we will study about the different techniques that can be used to save energy, what should be the various different techniques that can be used in our IoT based system to save the energy of the devices. Okay. So, let us start with the first topic, that is differentiate between various types of memory. So, under which we will study about the memory hierarchy. So, this is the memory hierarchy. Here you can see that we have a cache memory, okay. We have a main memory, secondary memory, and a tertiary memory, start from the primary memory. So, if you are looking into this hierarchy, you can see that from the cache memory to the main memory and from towards the tertiary memory, what you will observe? You observe that there is a larger size will be increased, cost will be lower, and the speed will be lower if we are going from the one memory to the another memory. Okay. So, in memory hierarchy we have a registers, So, we are talking about the registers. It is basically registers. What is the meaning of the registers? We will see first. The registers are basically used to store the information on a permanent or temporary basis. So, in the previous lecture we have seen that we have a general purpose registers that is used to store for a general purpose. They are used to store the any type of data, that is general purpose, and some registers may be in the category of special function registers that is used to for a specific functions. They can only store some specific value, not for general purpose, that is any value. Okay. So, registers are basically used to store the information that can be that can flow in our any microcontroller. So, it usually have a one CPU cycle to access. To access it you use only one CPU cycle. It has a cache memory, another one is the cache memory. Cache memory is one of the fastest memory in our system. Okay. Here you can see that cache memory is at the top and it has a more speed as compared to another. It is at the top of the memory hierarchy. So, it has a CPU cache memory, TLB, okay, page cache. They are all deploying in utilizing the static RAM memory. Okay. So, if we are looking into the main memory, this one main memory is at the lower hierarchy than the cache memory. It has a lower speed as compared to cache memory. We have a dynamic RAM. RAM basically a volatile memory. Okay. RAM means volatile memory. As long as the power supply is on, its contents remain in the system. If you are not as soon as you are shut down the power supply, RAM will not work. its content will not be in the memory. Okay. So that is a volatile memory, that is dependent on the power supply. As long as the power supply is on, its content will remain in the chip. After that is secondary memory. Here you can see we are utilizing the secondary memory. Secondary memory like hard disk. Okay, these hard disk. So it has a lower in memory hierarchy. It has a lower space than the main memory. Okay, so it has a it is a larger in size. Okay, but lower cost and lower speed as compared to the cache and the main memory. We are talking about a secondary memory. Okay. After that we have a tertiary memory. Tertiary memory means they are utilizing the tape libraries. Okay, they have a special locality, temporal locality. So tertiary memory has a lower speed, very much lower speed, lower cost, but and larger in size as compared to other memory devices in the memory hierarchy like main memory, cache memory, secondary memory. Tertiary memory has a lower speed and lower cost. Okay. After that in memory hierarchy, to exploit the memory locality. So in our IoT based system, we are utilizing the CPU, input output devices. In CPU we should have a memory. So we are talking about that memory, what type of memory we can be used in our IoT based system. So next topic is CPU cache hierarchy. So we are talking about the differentiate between various types of memory, under which we will study the CPU cache hierarchy. So CPU cache hierarchy, basically we are looking into this. You can see that at the top of we have a CPU, cache static RAM, main memory, storage, hard disk and flash memory. From top to bottom we can see that cost will be less and the speed is also slow. Okay. So CPU makes use of small, fast and very expensive registers. So in CPU there is a large number of registers we are using, and these registers are used to save the information on a temporary and a permanent basis. Okay. So main memory is cheaper and greater capacity, but take much longer to access. We are talking about the main memory. It is cheaper, it has a low cost, because from top to bottom cost is decreasing as compared to the main memory. As compared, we are comparing with the cache memory. Okay. So it is cheaper and greater capacity, but takes much longer to access. Its execution is speed is less as compared to the cache memory. Okay. So CPU cache is used to exploit locality. What is the meaning of locality? Locality means the information which is stored in memory, it has some location, memory location. Okay. It has some address location, we are talking about that. So CPU cache is used to exploit locality, keeping copies of data likely to be used again in faster access memory to reduce the average time taken to access the data. So what is the meaning of these lines? The meaning is that the CPU cache is used to exploit locality. Okay, to locate the information that is written in the memory, and keeping copies of data likely to be used again. So the information we are going to use again, its copies of that data is located in the cache memory, and we can retrieve that information again and again, and its access is faster as compared to other memory. Okay. So CPU cache is has a much larger speed as compared to other memory, there is a main and a hard disk or flash memory. Okay. Its execution is fast and its cost is also low. Okay. So cache sits in between the fast static CPU registers and a slow memory, both in terms of cost and speed. So CPU cache memory, it lies in between the main memory and CPU, and it has a fast execution and low cost as compared to the another devices. So in terms of cost and speed, we can prefer cache memory as compared to the main memory and the tertiary and the secondary memories. Okay. So now we will talking about the virtual memory. Virtual memory, what is the meaning of virtual memory? So to exploit locality, use the main memory as a cache. We have seen that. Okay. So virtual memory, here you can, this figure you can see that there is a concept of paging and segmentation here. Okay. You can see this concept in your embedded devices subject. So in paging there are various types of pages. Okay. They are utilizing the logical address. Okay. So each page has some equal size, they they have some information. Okay. So they are mapped into a page table. In page table, what is mapping means that each page has its location. Each page has some its location. You can see that this page has a location of 0. We are mapping into the page table. Okay, page table is like a your index. If you are notebook, there are 300 pages, and what is the content at particular page, they have some indexing. Okay, this is like a indexing of the book. So this through this page table we are converting the from the page to the frames. Okay, page to the frames. So we are converting from the logical address to the physical address. Okay, so in physical address, paging is a logical concept, and paging is a physical concept. Physical address, they has a physical address. Here you can see that we are dividing the our physical address into many frames. Okay, many frames. And when we are utilizing these frames, swap in swap out means that they can, through memory management technique, we can utilizing the particular frame. They are if we are utilizing this frame, not utilize this, if then they can swap in swap out. Okay, so this is the memory and this is the secondary memory we are utilizing it. So paging which currently executes in memory, it is possible to push the rest to the secondary memory. So what is the concept of swap in swap out? If in memory management technique, if one memory, for example, if this is a memory, it is utilizing 2 kilobyte, and our CPU takes 1.3 KB. So what we will rest? We will rest with the 0.7 KB. If another memory have 2 KB and it need to access 2.7 KB, it need 0.7 KB more. So through memory management technique, it can utilize 0.7 KB from the previous memory. So this is the memory management techniques. All this we done through swap it and swap out. So physical address space now include both physical memory and the secondary memory. So physical address has both the physical memory as well as the secondary memory. That is, secondary means memory means hard disk that is used in our laptop system. Okay. So operating system now has to handle all the translations and other related overheads. So operating system now has to handle all the types of memory, secondary memory. It has to utilize the concept of the paging and the segmentation. So this is the memory organization. We have a computer memory. This computer memory is divided into a primary memory and a secondary memory. So primary memory further divided, we can see that in our system it has a RAM, that is a volatile memory, and ROM, that is a non-volatile memory. Again RAM is divided into a SRAM, DRAM. SRAM means the static RAM and DRAM means the dynamic RAM. And ROM, that is a non-volatile memory, again it is divided into a PROM, programmable ROM, EPROM, electrically erasable programmable ROM, electrically erasable it means, and it is erasable PROM. Okay. After that, secondary memory is divided into a hard disk drive HDD, solid state drive SSD, compact disk, floppy disk, magnetic tape. So HDD memory we are utilizing in our system, but some of what in today modern present time we are utilizing the SSD memory. SSD memory has less space, but is more execution speed is fast as compared to HDD. Okay. So SSD means solid state drive and HDD means hard disk drive. Okay. We will see here explanation of all these things. So types of computer memory we have divided into primary, secondary. We have seen in our previous slide. So first we will start with the cache memory. In the previous slides we have seen that cache memory is one of the fastest memory among all the memory utilization, memory that is utilized in our IoT based system. So this they are temporary storage area known as a cache. Basically the information we are executing, temporary information, they are utilizing the cache memory. Okay. So it is more readily available to the processor than the computer main memory. So it is also called CPU memory. It is basically a main memory, CPU memory, that is utilizing cache memory, because it is typically integrated directly into the CPU chip or placed on a separate chip with a bus connected with the CPU. So, CPU is directly utilizing the cache memory in our system. After that, we have a RAM, random access memory. This is a volatile memory. The term is based on the fact that any storage location can be accessed directly by the processor. Okay. It has a two categories further: dynamic RAM, static RAM. Dynamic RAM means that DRAM. It is a type of semiconductor memory that is typically used by the data or a program code needed by a computer processors to function. So, RAM is also called a data memory, because as long as the power supply is on, RAM contents will be in the system, and it is a volatile memory, and it is dependent on the power supply. Okay. It works only when power supply is on. So, it is called a data memory because data is not a permanent. It is data is flow in the system whenever the power supply is on. Okay. After that, we will see the static RAM. Static RAM, it is much better than the dynamic RAM. It retains data bits in the memory for as long as the power is supplied to it. We have seen that. So, unlike the DRAM, we store bit in cells consisted of capacitor, transistor. SRAM does not have to be periodically refreshed. So, what will happen in case of static RAM? The contents we do not need to be refreshed again and again. Okay, but in case of DRAM, periodically we need to refresh the contents again and again. Refreshing means that we have to retrieve the contents again and again. So, after that, we have another types of memory. SDRAM, we have a data double rate SDRAM. As the name implies, data rate will be double. So, it is basically called a DDR SRAM. In our today laptop devices, you can see that DDR RAM. Okay. So, it is SDRAM that can theoretically improve memory clock speed at least 200 megahertz. So, our execution rate is faster as compared to simple SD memory or SRAM or dynamic RAM. So, after that, double data rate for synchronous dynamic RAM, DDR4 RAM. It is a type of DRAM that has a high bandwidth interface and is the successor to the previous DDR2. So, one we have a DDR1, DDR2, DDR3. After that, we have a nowadays we are using the double data rate 4. So, versions. So, it is coupled with higher data rate transfer speed. It is transfer speed is large and it is allow for dual inline memory module. So, they are using the dual DIMMS modules. So, its speed it has a largest storage area and its execution speed is fast as compared to other devices. Its execution speed is mainly in the gigabytes, okay, per second. After that, we have a Rambus dynamic RAM, DRD RAM. Rambus dynamic RAM. R means the Rambus. So, it is a memory subsystem that promised to transfer up to 1.6 billion bytes per second, billions of data at a faster rate. So, in the previous you can see that the memory we are talking about, it has a transfer rate from megabyte per second to gigabyte per second, gigabyte per second, gigabyte per second. But in Rambus dynamic RAM, it has a data transfer rate up to 1.6 billion bytes per second. How much data rate? This is very much longer. In 1 second, you can transmit information up to 1.6 billions of bytes. It is possible nowadays. So, after that, we have a read-only memory. Read-only memory means ROM. It is a non-volatile memory. It is independent of the power supply. If you are shut down the power supply, its content will remain in the system. Okay. So, it is a type of computer storage containing non-volatile permanent data that can normally only be read and not written to. So, the contents that is used in our ROM, only we can read it and we cannot write its content as in the RAM. RAM we can read and write both, but in ROM it is, as the name implies, read only memory. We can only read the contents from the memory, we cannot write the content into the memory. So, it is a read only memory, it is a non-volatile nature. So, further classification of read only memory is programmable ROM, it is a PROM. PROM is basically a, it can be modified only once by a user. So, it enables a user to tailor or microcode program using a special machine called a PRO programmer. So, it can be used only once, and to burn a chip to integrate the data into the memory, we need PROM programmer that can be used to programming the chip. After that we have a EPROM, erasable PROM. It is a programmable read-only memory and can be erased and reused. We cannot use only once. Through erasable PROM, we can erase the things and reuse our chip. It ensures shining intense ultraviolet light. How it can be happen? If we there is a window in our memory chip. Okay, through this window we can expose that area to ultraviolet light, and this ultraviolet light will be responsible to raising the contents of EPROM chip. After that we have electrically erasable PROM. We can erase the contents of a PROM chip. This is user modified and it can be reprogrammed repeatedly through the application of higher than normal electrical voltage. That is through electrical voltage we can erase the contents of EPROM chip. After that we have a virtual memory, as we have seen in the previous slide. Virtual memory, a memory management technique. Memory management technique means these are task efficient. How much memory can be utilized, allocated and reallocated, all these things done in MMU, memory management technique, where secondary memory can be used and if it is were part of the main memory. So, in virtual memory there is a main memory and we can say that secondary memory is a part of the main memory. So, virtual memory we are going from the logical address to the physical address as in seen previous slides. So, after that we have a concept of a WSN, an overview of wireless sensor network toward Internet of Things. So, first topic point is what is WSN? WSN, 3 words: wireless sensor network. Network means, as the name implies, there is a network of various sensors that are communicating with each other wirelessly. So, network means there is network amongst the devices and all are connected wirelessly, and in WSN we are using sensor nodes as the name implies. So, it is basically a infrastructureless network of large number of sensor node and they are distributed among a ad hoc manner. And we will take some example. So, it is a network of nodes that can work in a cooperative way. Thus, various types of sensors that we are using in a WSN all are works on a cooperative way. They are able to sense the data and control the environment surrounding them. So, these sensor nodes, we are talking about a sensor node, are linked via wireless media. So, nodes use this connection to communicate among each device. So, what will happen? I am erasing the things here. So, in a WSN there is a large there is a some area, okay, in agriculture area for example. There are large number of sensor nodes we can deploy according to our applications. These are sensor nodes, okay, these are sensor nodes and these sensor nodes are communicating with each other in a cooperative way, okay. So, these sensor nodes are connected with each other. They are connected with each other. They are intelligent enough to transfer information, and distribution may be in the star topologies, mesh topologies, and these sensor nodes are again connected to a base station. BS means base station, that is a master station that are controlling the things, and through this base station we are connected with the computer, that is user are connected to, through this user are connected, okay. So, sensor nodes have a EU unit, like control unit, etc. So, architecture of a typical WSN consists of following 3 components. In WSN we have 3 components: sensor nodes that is capable to sense the data. We have a gateway. This is gateway can be employed here. Gateway means that can pass the routing the data to the user, that is a computer, okay, and the observer, that is a user. So, sensor nodes and gateways constitute the sensor field. We will see in our next slide that this is the typical diagram of architecture of WSN. Here this is the sensor field. In sensor field we can deploy many large number of sensor nodes according to application. These sensor nodes are connected to the gateway, we can say that base station, and through base station wirelessly we connect with the users, computers, okay. So, sensors and the gateway constitute the sensor field here mentioned, and the gateway and the observers are connected via network, okay. So, this is about the WSN. So, in components of WSN is power and power management unit. We need power management unit, how much power supplied to the sensor nodes, because in our system WSN sensor nodes should have very less power supply. We have a sensor unit that is responsible to sensing the data from the environment, analog data. We have a microcontroller unit for processing purpose. It has a processing unit as well. We have a transceiver unit that is a communicating unit, because we need to connect wirelessly to the gateway and further pass information to the another devices. After that, in the last topic, we will discuss the identify the techniques used to save energy. So our main purpose is to save the energy of the sensor nodes. So for that we can use thin film batteries. So LG has created three new types of batteries. We have seen that LG curved, stepped and cable. Three types of batteries they have deployed. All can be responsible to save energy. So these batteries will be suitable for all of the functions of IoT which requires very high flexibility and high tolerance. So they motion, solar and thermo energy harvesting technology. It is self-powered wireless technology. So what is happened there? What happened there? There are batteries that can be manufactured by some of the companies which has a very less power consumption and through which we can save energy. So power management integrated circuits PMIC with dual input that enable efficient harvesting from both solar and vibration energy that can eliminate the need for and extending the life of batteries and IoT devices. So what is the purpose is that in IoT based system we are deploying the devices. These devices can be able to consume very less power and through modernization, through development of some latest battery, we can save energy of our system. We are talking about that. So in last slide we can see that Microgen system that is used in the US company, it launched Bolt series of MEMS. Okay. So these Bolt series of MEMS have a very less power consumption as compared to others. So these are responsible to convert the mechanical vibration to electrical energy. Okay. Startup Imprint Energy, US company, it developed ultra thin zinc polymer batteries that is have a very that can save our energy for wrist-worn devices. Okay. The University of Washington in US also came up with a new RF wireless energy transfer Wi-Fi technology that can not only transfer energy but also power the individual devices. In our soon we will see all these types of battery in our market. So in last slide we can see that the most important drivers that can used in our IoT power sources are wireless smart self charging capability, environmentally friendly and cost effective materials, flexible shape, small size, enhancement in energy and power density, longer lifetimes. All are the requirements in our today world. We have to take care all those things, that is a low power consumption, flexibility, small size, etc. So thank you everyone. I hope you have enjoyed my lecture. Thanks for your for watching my video.